The following video is going to be over completing the traverse computations using the WolfPack program. We're going to be using our homework that we did in class for the traverse project. We have a 3-segment traverse that we'll use the program for. So let's get started. The first thing that you want to do is you want to go to your desktop and get the WolfPack program started. So it'll have a little icon with the wolf's head. It's underneath the survey toolbar. So get that started. I've also added the instructions over here on the right hand side in a document format. Now, just a little bit about the program is it was developed by the professor at Penn State, and it not only calculates traverse, but it can calculate the area of our traverse. We can do side shots and a lot of other different things, but this is what we're going to focus on today is our traverse calculations and our side shot calculations. Now, the data that we're going to need for the program is going to be our horizontal distances and our average angles to the right. Remember, in a closed traverse, the angles that we actually are going to be using is our interior angles. Our side shots will be using our side shot angles. Now, so the data that we're going to say is when we create this, is we're going to create it into a text file. Okay, so you're going to start out with a title, and you're going to say, okay, I'm going to title this Crew 1 Northeast Data, whatever your crew number is and wherever you start. The other pieces of information is the number of angles. How many angles do we have in this one? We have 1, 2, 3 angles. Okay, so and how the data was collected is very important. We went counterclockwise. We went 1, 2, and 3. We went in a counterclockwise rotation. So that's important for the program to understand. Now, the next thing we'll know is our known azimuth. So our known azimuth is, this is our initial azimuth, and then we took the first line. Our known azimuth is going to be this first line that we're calculating. The next thing is going to be the distance from point 1 to point 2, and then our average angles in degrees, minutes, and seconds. Now, we'll also need to know our closing angles, and we have to know our coordinates for the start point. All right, so let's get started. Now, you're going to go ahead and go open up WolfPack program. You're going to go File, New, and this is going to start allowing you to type in your document information. Okay, so that's the first page of the information. So the data that you're going to need is, remember, I said you're going to need a title. So you can say Crew 1 Northeast Data. Okay, now the next part is the number of angles that we have. In this one, we have 1, 2, and 3 angles. So we've got 3 angles, and the 1 represents us going counterclockwise. The next thing it asks us is we have to put in our known azimuth, the very first line of our azimuth. So what you're going to do is you're going to take, for example, you're going to take the 185 degrees, 15 minutes, and 30 seconds, this known azimuth, and you're going to add the 18 degrees, 21 minutes, and 25 seconds. That's that initial angle. We called it either an either angle or initial angle. And then that's going to give us our initial azimuth from point 1 to point 2. So that's going to be 203 degrees, 41 minutes, and 55 seconds. Now in the program, you don't need to add degrees, minutes, and seconds. So you're just going to put in spaces. So you're going to say 203 space 41 space 55. Okay? The next thing that you're going to put in is the very first distance line. You're going to put in this point to this point. So I'm going to type in 138.345. That's the distance, space, and the initial, this angle right here. It's also our closing angle. So remember, we went 1, and then we moved to 2, then we moved to 3, and then we had to move back to 1, and we called that our closing angle. I'm going to move this over here. That closing angle would be that last shot. Okay, so I'm going to type in 47 space, I'm sorry, I need to put in a comma here. So 138.345 comma, that's our length, and then our angle, 47, 17, 30. Okay, so that's this piece of data here, and that's our first angle. The next thing we're going to put in is the next segment, the point 2 to 3, and the angle at 2. So we're going to type in 103.285 space, sorry, keep forgetting that comma, space, 32, 40, 45. Okay, so that's this piece of information here, 103.285 feet, and our angle to the right. The next one is going to be from point 3 back to our initial start point. The distance is 75.855, comma, and that angle here is 101 or 100 degrees, 1 minute and 30 seconds. This data here was wrong on the data table, so I just wrote underneath what the corrected information is. So that angle is 100 degrees, 1 minute and 30 seconds. Now you do need to have the 0 in here when you write that. You have to have two places. Okay, so the next piece of data is we've got our 3 angles in. We have to have a known start point. Now the program requires you to put it in the X comma Y format. So we're going to put in the easting value first. So 507.101.628. This piece of information is always going to be given. So the next one, the Y value, or our northing, is 1524088.644. Okay, so that's our data. Now I'm going to go ahead and close that out. So that's this piece of information here. The next thing I want you to do is go ahead and take File and then Save As. You're going to save this as Traverse Example Homework 7. Okay, I believe, or we're just going to call it Traverse Homework. I don't remember if it's 6 or 7 at this point in time. So I'm going to say Save. Now, excuse me. The next thing that you need to do is you're going to do the WolfPack Traverse Computations with the compass rule adjustment. Now, the program at school is a little different than the one that I have here at home. So the program, when I do when I go to Programs and I come up here to Traverse Computation, I don't get this first compass rule adjustment, but you all may. If you don't, then it's going to look like mine. So if you don't have the compass rule adjustment picture, then don't worry about it and go ahead and click on the traverse type of computations. So you're going to do a polygon traverse with angles, and yours might look like this, so it says polygon traverse with angles. Go ahead and click it. It'll do the exact same thing, so don't worry about it. So we want the polygon traverse with angles because we did angles, interior angles. Okay, so you click OK. And now you select the file that you just created. Mine was called Traverse Example Homework. Whatever you called it, go ahead and click and then go open. Now here's the other thing. Make sure you know where you save your data when you create that Save As file. So you open, and this is what the traverse looks like. You can go ahead and print this image out if you wish. I'm going to go ahead and just close. Now what it does is it's going to create, let me go ahead and scroll down here, it's going to create this print file. What this is all your results. So it tells you, I'm going to move this over here, it tells you you started with unadjusted angles 47, 17, 30, 32, 40, 45, and 100 degrees, 1 minute, 30 seconds. So that's what these values are. Then it adjusted it. It's telling you that your angular misclosure was negative 15 degrees. So we didn't have a closing angle. So they had to adjust these angles and added 5 degrees to each one. All right. The next thing that you're looking at here is the azimuth calculations. If you refer back to your homework or the uploaded solutions, you can compare the calculated azimuths with the azimuth computed by the Traverse program. Now we have the unbalanced latitudes and departures. And remember, when these are summed up, if these don't equal 0, then we know that the traverse didn't close. And this is our length of our total traverse. The next part tells us that we need to balance our latitudes and our departures. So it says, all right, here's what the departures and the latitudes are. Remember, a negative departure means it's going, if I'm looking at this, I'm at point 1, and it's saying I'm going west, a negative 55.6224, and south, a negative latitude of 126.688. I'm going east, 85.994, and then I'm going north, 57.18. So those are our latitudes and departures. From there, we can get our calculation of our coordinates. Now, the program goes ahead and tells us our linear misclosure and our relative precision. It also tells us our area in square feet. Now, there might be a little bit of difference in here because of rounding when you use your calculator to do the area by coordinate method. The last part has to do with our adjusted observations. So they adjusted the lengths. Remember, our original length was 138, over here was 138.345, and now it's 138.362. The azimuth that we originally calculated for here was 203.4214. And now we can see that it's 203.42. I'm sorry, we originally said it was 203.4155, and now we can see that it's a new azimuth of 203.4214. Okay? Now, the next thing I want to show you is the side shot calculations. All right, before you go out, what I'd like you to do is go ahead and print this information out when you go to do it for your homework example, and you'll be using this program to complete your Civil 3D project. Now, what I want you to remember is I'm going to show you in the Civil 3D project how to use these coordinates to input and create a plat plan for your Traverse project. All right, so go ahead and print this this sheet out and save it for later. All right, so now we're going to talk about the side shot calculations. I'm going to go ahead and close this down. And over here in the instructions, what you're going to show is you're going to do coordinate computations based on the forward. So if I go back to my programs over here, I'm going to say my programs. I'm going to come down here and go coordinate computations, and I'm going to say forward. All right. Now the first thing that it does is it's going to ask us for our occupied station. When we're looking at these, we're going to say our occupied station is going to be 0.2 because we're going to set up here and we're going to rotate this angle. All right. Now you're going to have to get your data for what that coordinate was from what you previously printed out. Now you're going to have to go back and get the data for the occupied station. So like I said, we're at 2 and we're going to the northwest. So my occupied station coordinates, I wrote those down. So that's going to be, the x coordinate is your easting, 507.046.006. Make sure you type these in correctly because if not, you're going to get a bit of an error. Now the next is my y coordinate, my northing, 1523.961.955. So let's double check those. 507.046.006 and 1523.961.995. Now, I need either the backside coordinates or the back station coordinates, that would be our 0.1, or the azimuth. And I'm going to go ahead and use the back azimuth. Now remember, you need to get your back azimuth is we calculated, and from the WolfPack program, it told us what our azimuth from 1 to 2 was. And what we'll need to do is calculate the back azimuth, meaning that I need to know the azimuth from 2 back to 1. So what we're going to do is we're going to take a look at our data. We'll go ahead and sketch it up and I'll explain it. What we're looking at is we're sitting at point 2. And we're looking back to the northeast. That means the original azimuth that we had from the northeast down to point 2 was 203 degrees, 42 minutes and 13 seconds. So make this a little bit bigger. So our back azimuth is going to be the 203 degrees, 42 minutes and 13 seconds. And since it's greater than 180, we're going to subtract 180 degrees to get our back azimuth. So our back azimuth that we're going to type into here is going to be 23 degrees, 42 minutes and 13 seconds. Now, make sure you use your adjusted azimuth at the end of the traverse calculations to get your back azimuth for your side shots. So the back azimuth is going to be 23 degrees, 42 minutes and 13 seconds. Okay, so if you're looking at the sheet, instruction sheet, this is what the information is saying here. All right, so you go, okay, and now you're going to input information for the type of survey data. Now this is going to be a traverse, so I'm going to click on traverse, and its distance is going to be the distance from point 2 to the side shot, or whatever point you're setting up to the side shot. So 76.815 is the distance, and then it's going to say to the angle to the right or the azimuth line. I'm going to say the angle to the right because that's what I collected, the 309 degrees, 41 minutes and 35 seconds. If you're looking at the data, that's this side shot up here. So I'm going to put in the angle to the right, 309, 41, 35 seconds. All right, now you're going to go ahead and click OK, and what comes up is going to be your information. So the way that I've got this set is I'm setting on point 2, and I've got an angle to the right of 309 degrees, 41 minutes, 35 seconds, and a distance of 76.815 feet, and I have an azimuth of 333 degrees. That means the azimuth going out this direction is 333 degrees, 23 minutes and 48 seconds. Now what it's going to do is it's going to calculate the departures and latitudes, and it's going to give me the solution to the northwest coordinate. And this is the solution. So I'm occupied at 2, so make sure your data matches, and I'm citing the northwest coordinate. So this would be your cited coordinates. Okay, so what you're going to do is you're going to go ahead and print these for each of your project points, your side shots. All right, that's it for this video. The next video will be on how to use the data that you got for the coordinates and type those into the using the Civil 3D program. All right. Thanks.